Welcome to our channel, where we embark on an intellectual journey through the cosmos, seeking to unravel the mysteries that lie at the heart of existence. Today, we confront one of the most profound questions ever posed by humanity. Is the universe real? Or are we mere actors in a cosmic theater of illusion? Join us as we delve deep into the realms of science, philosophy, and metaphysics to uncover the truth behind reality itself. In this exploration, we'll traverse through various perspectives, from the illusion of reality and the simulation hypothesis to the enigmatic nature of quantum mechanics and the philosophical underpinnings of time itself. Each section offers a unique lens through which to examine the ultimate existential question: is the universe real? Our perception of reality is shaped by our senses, which can sometimes deceive us. Optical illusions demonstrate how easily our brains can be tricked into seeing things that aren't there. But what if our entire reality is just a grand illusion? This idea has been explored by philosophers throughout the ages, from Plato's allegory of the cave to Descartes' famous dictum, "I think, therefore I am." Could it be that what we perceive as reality is merely a construct of our minds? Dr. Lisa Sanchez, neuroscientist: our brains are powerful reality generators, but they're also susceptible to biases and illusions. Understanding the neural mechanisms behind perception can shed light on the nature of reality and how it's constructed by the brain. The concept of reality as an illusion has fascinated thinkers for centuries, prompting explorations into the nature of perception and consciousness. Descartes, in his Meditations, famously doubted the existence of the external world, positing that all he perceived could be the machinations of a deceitful demon. This radical skepticism challenged the very foundations of knowledge and reality, leading to profound philosophical inquiries. Plato's allegory of the cave serves as another compelling exploration of the illusion of reality. In this allegory, prisoners are chained inside a cave, facing a wall where shadows cast by a fire behind them are the only reality they know. Upon being freed and experiencing the outside world, the prisoners realize the true nature of their reality and the illusory nature of the shadows they once believed to be real. This allegory highlights the transformative power of knowledge and the limitations of perception in shaping our understanding of reality. As we contemplate the illusory nature of reality, we're drawn to the intriguing possibility proposed by the simulation hypothesis. This theory posits that our perceived reality could be a meticulously crafted simulation, akin to a highly advanced computer program. In a universe where perception is malleable, could it be that our existence is merely a digital fabrication? One of the most intriguing theories to emerge in recent years is the simulation hypothesis. This idea posits that our reality is akin to a highly advanced computer simulation created by a more technologically advanced civilization. Proponents argue that if future humans or another intelligent species could simulate entire universes, it's highly probable that we're living in one such simulation ourselves. But how plausible is this theory? Philosopher Nick Bostrom: the simulation hypothesis raises profound questions about the nature of reality and our place within it. While there's currently no direct evidence to confirm or refute the theory, it serves as a thought-provoking exploration of the boundaries of human knowledge. Imagine a digital realm where the laws of physics are mere lines of code and reality is but a holographic projection. Visual representations of simulated worlds and computer algorithms could enhance our understanding of the simulation hypothesis, illustrating how complex systems can arise from simple rules and interactions. As we grapple with the notion of reality as a simulated construct, we're compelled to delve deeper into the mysterious realm of quantum mechanics. Here, at the subatomic level, reality behaves in ways that defy our classical understanding, challenging the very fabric of our perceived universe. Quantum mechanics, the strange and perplexing realm of the very small, challenges our notions of reality at its core. In the quantum world, particles can exist in multiple states simultaneously, and teleport across vast distances instantaneously. The famous double-slit experiment demonstrates that particles can behave as waves or particles depending on whether they're observed. This raises profound questions about the nature of reality. Recent experiments by John Clauser, Elena Specht, and Anton Zellinger have shown that the universe is not real locally. Quantum entanglement indicates that distant particles can affect each other instantaneously, contradicting the principle of locality. This challenges the notion of an objective reality with properties that do not depend on consciousness. Physicist John Stuart Bell stood against the idea of local reality, proposing that quantum physics is not absurd, leading to experiments confirming that the universe is not locally real. Moreover, the theory of the holographic nature of the universe suggests that everything we perceive is three-dimensional, but happens in two-dimensional space. The ADS-CFT correspondence theory relates to string theory and explains that black holes encode information on their surfaces. This brings us to the question of whether the universe is a hologram, a concept that holds mathematical value but is yet to be confirmed. Beyond the scientific realm, diverse perspectives from cultural and spiritual traditions offer alternative interpretations of the enigmatic phenomena observed in quantum mechanics. From ancient Eastern philosophies to indigenous cosmologies, these perspectives enrich our understanding of reality by emphasizing interconnectedness, consciousness, and the inherent mystery of existence. As we contemplate the intricate dance of particles in the quantum realm, we're led to ponder the fundamental nature of time itself. Is time an immutable force, marching inexorably forward, or a flexible construct shaped by our perception and experience? The universe could be a complex illusion, and time, one of the most fundamental aspects of our lives, may not be what it seems. Time is a flexible construct created to measure change and order the chaos of our existence. Whether time is an objective reality or a construct shaped by individual experiences and needs remains an open question. The concept of time has perplexed thinkers throughout history, leading to diverse philosophical and scientific interpretations. Ancient civilizations viewed time as cyclical, repeating in predictable patterns such as the seasons or celestial cycles. This cyclical view of time reflected the cyclical nature of life and the universe, symbolizing renewal and continuity. In contrast, modern scientific theories such as Einstein's theory of relativity and quantum mechanics present a more dynamic and nuanced understanding of time. According to relativity, time is not an absolute quantity, but is intertwined with space in a four-dimensional continuum known as space-time. This unified framework describes how the fabric of space-time can be curved or warped by the presence of mass and energy, resulting in gravitational effects that distort the flow of time. This shattered the traditional view of time as an independent variable and showed that it is an integral part of the fabric of the universe. In the special theory of relativity, time dilation occurs as objects move relative to each other at high speeds. The closer an object approaches the speed of light, the slower time flows for that object compared to a stationary observer. This phenomenon has been experimentally confirmed and has practical applications, such as in the accuracy of global positioning systems. In the general theory of relativity, Einstein extended these ideas to include gravity. According to this theory, massive objects like planets and stars cause space-time to warp, resulting in the perception of gravity. This gravitational time dilation also affects the flow of time, with clocks closer to massive objects running slower compared to clocks at a higher altitude. Again, this has been experimentally confirmed. Einstein's theories challenge the traditional view of time as an absolute and constant entity. They showed that time is relative, dependent on the observer's frame of reference, and influenced by gravity. The concept of causality, where cause always precedes effect, is also challenged. In relativistic theories, the order of events may depend on the observer's frame of reference, leading to situations where cause and effect may appear reversed or simultaneous. The discoveries in the field of quantum mechanics further complicate our understanding of time. Quantum mechanics describes the behavior of particles at the atomic and subatomic levels, and it introduces the concept of superposition, where particles can exist in multiple states simultaneously. The concept of time in quantum mechanics is different from classical physics, treating it as a discrete and quantized parameter. The very act of observation or measurement in quantum mechanics can disturb the state of a quantum object and affect its properties, leading to probabilistic outcomes. This uncertainty challenges our intuitive understanding of cause and effect, and raises questions about the nature of time itself. All these discoveries have challenged our traditional understanding of time and led to the emergence of new theories and perspectives. One intriguing theory is the block universe theory, which suggests that past, present, and future are not separate entities but part of a single, four-dimensional structure called space-time. In this theory, all events from the origin to the end of the universe coexist simultaneously, and our perception of the flow of time is limited to a single point on our world line. The block universe theory raises questions about free will and the nature of reality itself. If all events are predetermined and coexist in space-time, does free will exist, or is it an illusion? It also challenges our perception of reality as a static and unchanging structure, suggesting that the passage of time may be an illusion created by our limited perspective. As we conclude our journey into the depths of reality, we're left with more questions than answers. Is the universe real? The truth is, we may never know for certain, but perhaps it's the pursuit of truth and understanding that defines us as sentient beings. So, whether the universe is a grand illusion or an objective reality, let's continue to explore, question, and marvel at the wonders of existence. By embracing diverse perspectives, integrating visual elements, and fostering ongoing dialogue, we can cultivate a deeper appreciation for the mysteries of the cosmos and our place within it. Join the conversation in the comments section below, and let's continue to journey together in search of truth and enlightenment. Stay curious and keep exploring.